Okay, we're back on 4D. We're on page 85 now. And if you'll look back at the problems that we did on the page before, you'll see that we could easily identify domain and range from a graph because they were discrete points. It was not a whole bunch of points. It was just 4 or 5 points that were clearly marked on our graph. And we could take the discrete graph and we could write all the domains and all the ranges. And if they occurred more than one time, we only wrote them once. Okay, all that's well and good. However, now we have continuous graphs. We have graphs that from their endpoint, their starting point to their endpoint, they are continuous. There are no breaks in the graph. And there's 3 examples here of continuous graphs. So we're going to go ahead and ascertain that we are dealing with continuous graphs here. And when you're dealing with continuous graphs, the listing of your domain and your range are substantially different than what we did on the other page. So I want you to think about dollar ribbit, dollar ribbit. It sounds kind of silly, but this is sort of our land of gore kind of thing for this unit. This stands for domain, and it's left to right, left to right. Domain, reminding you that the domain represents the X values, the input. When we think left to right, we think horizontally, which of course is our X-axis. Ribbit, the range, is bottom to top, which represents going from a bottom up to a top, and that gives you a visual of our Y-axis. So when we're trying to identify what the domain of this little snippet of a graph is, so the graph has a starting point and an ending point, we look at the left to right on the X-axis. What are all the points that are on this graph? Well, it starts here, right here, and it goes to right here. This is the domain, right here to here. So you are looking at all of the values that go from here to here. We're going to write them as an inequality. So you are writing an inequality for these domains and these ranges. An inequality, and you are doing the small value less than the X less than the larger value, the largest value. So if you look at this graph right here, we are starting at -2. That's our smallest X value that's represented in this little snippet of the continuous graph. So -2 is the smallest value, and the largest value is +4, and it's less than or equal to +4 because the dot is circled in. If we look at the range, similarly, if we look at the range, we are looking at the Y-axis. How many points on the Y-axis does our continuous graph touch? So our smallest value from bottom to top is 0, and our largest value at the top is 3. And the line is underneath both of the inequality symbols because both of those dots are closed in. So every point on our continuous graph has a Y value that's somewhere between 0 and 3. 0 and 3. Every point that's on our continuous graph has an X value that's between -2 and +4. Okay, I'll come back and do another one here in a minute, and then we'll finish up this page. Thanks for watching.